Welcome to all of you. So our practical title is Wavelength of laser, and here we are using that laser. When we are child, we are playing with this one ND-YAG laser, and on the box the wavelength is already mentioned 532 nanometer, but using this practical we will find it. So our objective is to determine the wavelength of laser using diffraction of light. We already know what is diffraction, it is already covered. Apparatus, ND-YAG laser, screen, scale, holder, and diffraction grating. So this one is our diffraction grating. You can see we have a three different window: 100 lines per mm, 300 lines per mm, 600 lines per mm. The number which is indicate these number of lines which are exist in 1 millimeter. You can see this one is the 15,000 lines per inch. So per inch 15,000 lines are there. Each line which is opaque and rest of the material which is a transparent. So you can see due to this opaque line you can see different phenomena using the diffraction grating here. Now what happen, every time light will hit to that particular opaque lines and light will bend and we can see the diffraction of light. Okay, so this one is our simple arrangement of the experiment setup. Again I remind you, 100 lines per mm, it means what? Per mm we have 100 lines which is opaque lines, and rest of the material which is transparent looking like a glass. 300, it means per mm 300 lines, and the last one 600 per mm 600 lines we have. So just do some arrangement. We have a laser here, I already adjusted using the stand. Here we have a diffraction grating, and I just use this plain paper and making my screen. You can see I am using first 300 lines per mm grating. Okay, so this one is our simple experiment setup. Here is the diffraction grating and here is our screen, and I already adjusted the distance between these two, which is 15 centimeter, and I am denoted as the F. So now what happened, now laser will bombarded on the diffraction grating and we got these kind of pattern. The central spot which is considered as a C, zero order spot. After that we got some spot in right hand side and another left hand side also. So first one which is a first order, second spot which is a second order. Okay, so let's go with the observation table. We have a three different types of grating. Second one which is a resolution of grating. How we find the resolution of grating here? So simple, 1 divided by grating element. So just take an inverse, but remember this is lines per mm, and our resolution of grating unit is what? It is meter. So don't be forgot the conversion in meter. So 1 divided by 100 lines per mm, just take an inverse, I got 10 to power minus 5. Again 300, 1 by 3, 10 to power minus 5. 600 inverse, 1 by 6, 10 to power minus 5. So these are on meter. Now third one, distance between sample and screen, I already adjusted 15 centimeter. So convert into meter, it become 15 into 10 to power minus 2, which is in meter. Okay, so this procedure is done. Now order of spot, from the center, first point which is first order, second point which is second order. So it is same in left hand side and right hand side also. After that we are taking a mean, and using this value we got the wavelength of laser. I already mentioned here the formula, lambda is equal to something, and we already know lambda which is a wavelength of laser, D which is a resolution of grating, xm which is distance between zero order to first or second, and F which is distance between screen and grating. After that we are putting all the values in formula and we get. So let's start. I am using the laser bombarding on the 300 lines per mm grating, and we got these kind of screen. you can see on screen, this one is my central spot, maximum point, 0 order. This one is the first one, this one is the second one in right hand side, and this one is the first one and this one is the second one from left hand side. So every time I have to measure the distance from center to first, from center to second. So this one is the first order in right hand side, this one is the second order in right hand side, this one is the first in left hand side, this one is the second in left hand side. So measure from the center to first, second and so on, first mark and after the measure. So do these kind of arrangement in your practical exam, so you got these kind of diffraction pattern. So I already measured and I am writing my first order distance in left hand side. It become 2.7 10 to power minus 2, it means in meter, and from right hand side I got 2.3 10 to power minus 2. So just take a mean 2.5 10 to power minus 2. Okay, now second spot, the distance from center to second, it is 5.2 10 to power minus 2 for left hand side spot, and right hand side 4.8 10 to power minus 2. Just take a mean, I got 5 into 10 to power minus 2. Simple. Now simply I am using this formula, I am putting all the values in this formula. So let's check how much wavelength I found. So simply I am using this formula. Let's start with the D. What is D? D, which is the resolution of grating, I am writing for 300, it is 1 by 3 10 to power minus 5. What is my XM? Average value 2.5 10 to power minus 2 divided by M. For first order it is 1 in root XM value 2.5 10 to power minus 2 whole square plus F, it is 15 10 to power minus 2 whole square. So this one is the my value. Now I am simple using the calculator, I am calculate the root and after that multiply 1 by 3. I got it become 5.480 10 to power 5 and 2 minus 7. Okay, so convert into nanometer, 548 into 10 to power minus 9, so it became 548 nanometer, 548 nanometer. So this one is my first answer for first order, 548 nanometer. Okay, same you have to go through the second order spot. Just simply put M is equal to 2 and use this one mean, so you got another wavelength. I already calculate and I am writing direct answer 5 to 7 nanometers. So this one is the value I got. Now check for the 100 lines per mm. So you can see whenever I am using the 100 lines per mm grating, this one is my screen. From the first one I have to measure, this one is my central spot, first one, second one, first one, second one. Due to the 100 lines, the dots are very near. Okay, so same you have to measure the distance between 0 to first one, 0 to second one. So I am simply writing what are our measurement. So for the first one it is very near, the distance is how much? Yeah, 0.7 10 to power minus 2. Okay, which is in meter, 10 to power minus 2. Right hand side I got 0.85 10 to power minus 2. Take an average which is nearly 0.8 10 to power minus 2. And from the center second spot distance, which is I got 1.6 10 to power minus 2. Again I got 1.6 10 to power minus 2. So mean is same, 1.6 10 to power minus 2. Now again I am using same equation. This one is for 300, this one is for 100. but the equation is same. Here d is changed 10 to power minus 5 xm, which is changed. I got average 1.8 10 to power minus 2 m, again 1 under root xm value, so I am writing 0.8 10 to power minus 2 whole square plus f 15 into 10 to power minus 2 whole square. Okay, so this one is my value in this equation, and simply I am using the calculator. Just simplify the root and square, and first I simplify the power 10 to power minus 5 and 10 to power minus 2, it became 10 to power minus 7. So I writing 10 to power minus 7 and simplify using the calculator, I got 5.326. so convert into nanometer, 532.6 nanometer I got. So this one is the very near from the actual value. Okay, so just simple I am putting the result 532.6 nanometer. If you can put second one, you got 530. Now I am using the 600 lines per mm diffraction grating, and you can see on my screen only first point which is visible from the center, second one which is out of the screen. So measure from center to this spot distance, and distance between left hand side first order to center. Okay, so this one is the diffraction pattern for 600 lines per mm. So I am simply measuring, and after that I am noting the value, the distance in left hand side spot which is 5 into 10 to power minus 2, and the second one which is 4.9, take an average 4.95 10 to power minus 2, and if I am substituting all the values in the formula, I got 525 nanometer. So this one is our observation table, and I am taking the average of these 5 values, just add and divided by 5. So I got the average value 532.52. it is exactly near value from the ideal value. So I simplify and sum up the experiment with the result. I found the wavelength which is 532.52 nanometer, and if I am converting into angstrom, 5325 angstrom of the wavelength of this particular nanometer. And congratulations, we got the very fine result. Very thank you very much.